Welcome to University 360. In this video, we'll be talking about mathematical models of control systems. Now, the control systems can be represented with a set of mathematical equations known as mathematical models. Now, these models are basically used for analysis and design of control systems. Well, analysis of control systems means the finding of output when we know the input and mathematical model. So the design of control system basically means finding the mathematical model when we know the input and output. Well, we could use different equations and different functions we'll be using transfer function or state space model or differential equation model to solve these kinds of equations, right? So now what we'll do here is we'll be using differential equations. Now, as mentioned here, the mathematical model of a system is linear if it obeys the principle of superposition and homogeneity. Well, now what does that mean? It means that let's take two variables, y1 of t and y2 of t, and y1, y2 basically means the output, x1, x2 basically means input. Now what they're doing is, well, the system responds to the linear combinations of these input are a1 x1 of t and a2 x2 of t. Well, if it's a linear combination, then that would be equal to almost a1 y1 of t plus a2 y2 of t, where a1 and a2 are constants. Now this is the whole idea of mathematical model. Well, with this knowledge, we'll be moving to mechanical translation system. We'll be modeling this. Well, translation mechanical system moves along a straight line. Well, these systems mainly consist of three basic elements. Those are nothing but mass, spring, and dashpot, as mentioned here. Well, let's talk about some basics before delving into this topic. Well, if a force is applied to a translation mechanical system, then it is opposed by opposing forces due to mass, elasticity, and maybe the friction of the system. Well, since the applied force and the opposing force are in opposite directions, the algebraic sum of the forces acting on the system is zero, right? So it basically means when the applied forces equals the opposing forces, they will cancel out, right? They are equal. So that's what it means. Now, the three important terms we have to talk here is mass, spring, and dashpot. Well, we all know that mass is a property of your body, right? Which stores kinetic energy. Well, but if a force is applied on a body having mass m, let's assume then it is opposed by an opposing force due to mass. Well, this opposing force is proportional to the acceleration of body. Let's assume even we have elasticity and friction and whatnot. Now, we can actually design an equation from whatever we were discussing. Yeah, so F is equals to m into d square x by dt square. Well, whatever discussed till now, that's what the equation actually means. Now, the second part, spring. Well, spring is an element which stores potential energy, but if a force is applied on spring K, where's the spring? Yeah, here's the spring. Yeah, then it is opposed by an opposing force due to elasticity of spring, correct? So now this opposing force is proportional to the displacement, correct? Now let's assume mass and friction are negligible in this equation. So we will end up with the equation F is equals to K into X. That's what this equation means. And coming to the third part, dashpot. Now what is a dashpot? Well, let's assume if a force is applied on dashpot P. Here is the dashpot. Then it is opposed by an opposing force due to friction of the dashpot. Now this opposing force is proportional to the velocity of the body. Now in this case, let's assume mass and elasticity are negligible. So we'll end up with the equation F is equals to B into dx by dt. So here are the three most important equations while solving translation motion. In the next video, we'll be discussing about other types, and yeah, thank you.